Assalamu alaikum, dear students. This is the important class for class 11th. This is today's topic is collision and its types. First of all, we will try to define collision. Collision is a phenomena which is a very prominent phenomena in our nature. Suppose we see on the road, if we look on the road, a bike is colliding with a truck. It is a routine matter. Yours, in case of another example, I will give you in case of suppose a bat is colliding with a ball. That means this is all about the collision. Or we see a gas in gas molecules which are moving in all possible directions. They are colliding with each other. That means collision is taking everywhere in the nature. That means collision take place everywhere in the nature. Basically, we will try to see it when the two bodies collide. That means it is a collision is a natural phenomenon in daily life. We have seen plenty of examples of collision. Today we will see what is happening in collision. What are the quantities which are involved in the collision? Please remember, in collision only the two quantities are involved. One is the mass of the body. This is important. Mass and velocity of the body. Velocity. That means in collision, mass of the body is involved and the velocity of the body is involved. That means when one body collide with the another body, that means they collide, their masses collide. That means, or we will see one body is having one velocity, another body another velocity. That means these two bodies, these two quantities effect in a body when the two bodies collide, that the mass collides and their velocity collides. That means moreover when they collide, its velocity will go on changing. Okay, sir. That means we will see what are the quantities in physics in which mass and velocity are involved. And we will see, we have studied in the previous class. One is the linear. That means mass and velocity. That means when collision take place, in collision mass and velocity are involved. That quantities in which mass and velocity are, that is called momentum, linear momentum. If you remember previous class, linear momentum, in which that means in linear momentum we say it is a product of mass and velocity, quantity of motion, mass and velocity. That means in linear momentum mass is also involved, velocity is also. Kinetic energy, kinetic energy 1/2 of mv square. That means these are the two quantities which affect mass and velocity due to this. That means in collision mass and velocity are involved, but we know in physics linear momentum, mass are product of mass and velocity, linear momentum and kinetic energy 1/2 of mv square. That means there must be a change in linear momentum and kinetic energy. But we will try to see it how how things behave after collision. When the two bodies collide, they are having mass, they are having velocities. How things behave after collision. We will see how things behave after collision. So we have seen that in collision mass and velocity are involved, but when the quantities which are associated with the mass and velocity, in physics we have studied this linear momentum and kinetic energy. So there is must be change in linear momentum or kinetic energy. First, in order to study behavior of mass and velocity, suppose we will take examples here. Suppose this is the ground. Suppose here I have released a ball here at a height h above the surface of the ground. Okay, this is height h above the surface of the ground. In one case, suppose in one case I am releasing the ball, the ground rebounds for the ground is applying a rebound force in the upward direction. It rebounds the ball. Suppose the ball gains again the height h here. This may be one case, edge here, edge. That means after releasing the ball, the ground rebounds, applying a rebounding force on the ball and in the upward direction, and it again reaches to a height edge. This may be one of the cases. Okay. Suppose in another case, suppose I am again releasing the ball here at a height edge. Suppose, yeah, when it strikes on the ground, when ground rebounds it back, suppose it reaches at a height h dash, it is less than h. That means two cases. This is case 1, this is case 2. If we see the kinetic energy here, we know that initial velocity is equal to 0 here in use because we know that initially it is 0, it is released, it is freely fall body, it is initial velocity is final velocity becomes here v square minus u square is equal to 0 is equal to 2gh. you know that this is freely fall 2gh. ठीक है. अगर हम काइनेटिक एनर्जी की बात कर लेंगे, यहाँ काइनेटिक एनर्जी को किसके बराबर होते हैं? यू नो दैट काइनेटिक एनर्जी इज इक्वल टू 1/2 ऑफ एम वी स्क्वायर. दैट मीन्स आई हैव टू मल्टीप्लाई बोथ साइड्स बाय 1/2 ऑफ एम वी. व्हेन आई मल्टीप्लाई 1/2 ऑफ एम वी, आई कैन बिकम 1/2 ऑफ एम वी स्क्वायर. इफ आई मल्टीप्लाई 1/2 ऑफ एम, that 1/2 will cancel, that is mgh. This is the kinetic energy of this case first. This is the kinetic energy of case first. In second case, I apply the same formula here. It again having a final velocity v square is equal to 2g, but not h here. Height it has given h dash. I have to apply again here 1/2 of m v square, 1/2 of m, 1/2 of 1/2 and 2 will cancel, it's mgh. That means kinetic energy of this is equal to mgh, kinetic energy of this mgh. We know that means kinetic energy of first one is greater than 2. Why 1 is greater than 2? Because mass इसका same है, g भी same है, but value of h is greater than this h dash. H is greater than, that means why kinetic energy of first is greater than kinetic energy of the second. That means here the kinetic, it becomes the loss in kinetic energy. In particularly we say in elastic collision, in such type of collision in which there is no change in kinetic energy. That means kinetic energy of the system remains conserved. You have to do this. It does not have any effect in the kinetic energy because it reaches at the same height. That means kinetic energy of the system remains conserved here. Such type of collisions in which the kinetic energy remains conserved is called elastic collision. Elastic, मैं यहाँ बताऊँगा इलास्टिक को, मैं इन डिटेल में भी बताऊँगा इलास्टिक collision. In elastic collision, kinetic energy of the system remains conserved. In elastic collision here, it reaches at the height, the kinetic energy does not remain. It is called such type of collision called inelastic collision. In elastic collision, that means kinetic energy of system does not remain conserved. Now we will see in detail what here we will see in detail what are the, that means there are two types of collision: elastic collision and inelastic collision. Elastic, please try to remember elastic collision. Number 2, inelastic collision. In elastic collision, I will say here, elastic collision, kinetic energy of the system remains conserved. Kinetic energy of system remains conserved. Number 2 here, number 1 here, kinetic energy of system does not remain conserved. ये कैसे कंजर्व होती है, इसमें क्या प्रॉब्लम? बेसिकली व्हेन दी स्ट्राइक्स here, Here the air particles, it does not impart energy to the air particles here. It rebounds back here. Here, when this ball strikes here, it some part of kinetic energy is imparted to the air particles which are surrounding here. That means energy is lost here. Kinetic energy, total energy की बात मैं नहीं कर रहा हूँ. Kinetic energy, total energy दूसरा होता है. That means here the kinetic energy remains same. Here the kinetic energy of the system does not remain conserved. It becomes a system because here the air here when a ball is striking here, the molecules of the air are here. That means this is not imparting any type of energy to the air molecules. Here some energy is lost, kinetic energy, because it imparts some kind of kinetic energy to the air molecules. It becomes them a system, not a ball, but the system. Please remember the system. Kinetic energy of the system remains conserved. In this case, here momentum of system, not one particle, momentum of system remains conserved. ये क्या होता है, इसमें भी मोमेंटम ऑफ सिस्टम रिमेन्स सेम होता है, सिर्फ एक ही फर्क होती है. मोमेंटम ऑफ सिस्टम रिमेन्स कंजर्व्ड. मैं आपको बताऊं सिस्टम क्या होता है. मैं इफ यू रिमेंबर द प्रीवियस क्लास, सपोज दीज आर टू बॉडीज हैविंग मास, सपोज m1 m2, it is velocity is suppose u1, its velocity is u2. We know that u1 is greater than u2. After some time they will collide. After collision, that means its velocity becomes suppose v1. It's after collision, its velocity becomes v2. That's its mass v2. इसका mass m1 है, इसका mass momentum of system means momentum of, suppose this momentum is p1 and p2. P is equal, it's the total momentum of the system. That means p1 plus p2. It is equal to momentum of system p1 plus p2 after collision. अगर हम देखेंगे यहाँ मास u1 है, इसका मास भी u1 है, वेलोसिटी u1 है, ये मोमेंटम बराबर नहीं होगा. लेकिन इसका सिस्टम मतलब जितने पार्टिकल्स है सबों का मोमेंटम मिलाकर इसके बराबर होगा. इट मीन्स इज दिस कॉल्ड मोमेंटम ऑफ द सिस्टम. इट रिमेन्स कंजर्व्ड इन बोथ द केसेस, वेदर इट इज इन इलास्टिक कोलिजन, वेदर इट इज इन इलास्टिक कोलिजन. बट काइनेटिक एनर्जी ऑफ द सिस्टम, बट वी नो आल्सो दैट एनर्जी neither been created nor destroyed. The total energy remains conserved. Total energy, not kinetic energy, please. We have studied in previous class total energy. That means in this case total energy remains conserved. Total energy remains conserved. उसका क्या मतलब है? total energy remains conserved. Here also total energy remains conserved. Total energy remains conserved. Total energy is not kinetic energy. Total energy is the sum of kinetic energy, potential energy, heat energy, sound energy, all types of energy. That is the total energy. That means here when kinetic energy remains conserved here, but here the kinetic energy remains here the kinetic energy of the system does not remain conserved because some energy is lost here, maybe in form of the heat. But total energy, please note, there is a difference between kinetic energy, but the total energy of this in case of elastic collision is also equal to the total energy of the inelastic collision. And there is only one difference between the elastic and inelastic collision. That means the kinetic energy here remains conserved. In this case kinetic energy does not remain conserved. I have given you an example here. When I drop a ball here, after when it strikes the ground rebounds it back to its original position. That means its kinetic energy remains conserved. That means the air particles which are around it does not, the ball does not impact its transfer its energy to the air particles, so that the energy of the system, kinetic energy of the system remains conserved. Here some energy is lost, maybe in the form of heat or other here. That means here we say the kinetic energy does not remain same because it does not reach at the same height. That means the simple difference between elastic and inelastic collision is that means in elastic collision kinetic energy remains same conserved, but in inelastic collision kinetic energy does not remain the same. Momentum of the system remains conserved here. Momentum of the system means system is not a single particle, it's the whole particle. अगर 2 3 4 पार्टिकल मिलाकर जो भी बनता है उसको सिस्टम कहते हैं. टोटल एनर्जी इसकी भी और इसकी भी सेम है. टोटल एनर्जी दैट मीन्स अगर here kinetic energy lost, but it is lost in the form of heat or other, and we put together all the energy, it becomes, that means total energy remains conserved. But only one difference of this is between elastic and elastic collision, that is the kinetic energy in elastic collision is remains conserved. In this case it does not remain conserved. One of the special case of this this type of collision, that is called here in case of special case of inelastic collision. One of the special case of inelastic collision is also called a plastic collision. Inelastic collision, ये तो आपके सिलेबस में नहीं है, मैं बता रहा हूँ. इट इज़ द स्पेशल केस, वन ऑफ द स्पेशल केस ऑफ inelastic collision is that's called plastic collision. What is called plastic? Plastic means to stick together. Plastic collision. Plastic got me pasting of two things. When I paste two things together, this is called plastic collision. Suppose, simple example I give you, when a bullet hits a wooden base, that means अगर एक बुलेट है यहाँ, ये वुडन पीस को हिट कर रहा है, इट कोलाइड्स हियर, दैट मीन्स इट विल स्टिक इन ए वन बॉडी. दिस टाइप ऑफ कोलिजन इज कॉल्ड प्लास्टिक कोलिजन. इट इज़ द स्पेशल केस ऑफ inelastic collision. दैट मीन्स, या इन अनदर एग्जांपल, अगर सपोज मैं इफ आई पुट हियर a putty above the surface of the ground, if I drop here a putty, it will stick with the floor. This type of collision is called plastic collision. It is the special case of inelastic collision. That means when the two bodies stick together and behaves as a single body, that type of collision is inelastic collision. It is the special case of inelastic collision. That collision is called plastic collision. And in future, in next class, we will see what will happen in elastic collision and what will happen in the inelastic collision. इसका मास कैसे चेंज होता है, collision के बाद क्या होता है, we will see in the next class. I hope you have got it. Collision and it is type is elastic and inelastic collision. Only the one difference of elastic and inelastic collision is, in elastic collision kinetic energy of the system remains conserved, but in elastic collision kinetic energy of the system does not remain conserved. Please don't be confused. Total energy of the system of the elastic collision also is equal to total energy of the system. Total energy different होता है. Kinetic energy एक एनर्जी होते हैं. टोटल एनर्जी इज द सम ऑफ काइनेटिक एनर्जी, पोटेंशियल एनर्जी, हीट एनर्जी, साउंड एनर्जी. बट इसकी टोटल एनर्जी इसके टोटल एनर्जी के बराबर. बट ओनली द डिफरेंस इज इट काइनेटिक एनर्जी डज नॉट रिमेन, it is remains conserved. In elastic collision it is kinetic energy does not remain conserved. I hope you have. Thank you very much. Inshallah we'll meet in the next class. Thank you.